Hi, today I'm going to show you the chess game I've been working on. I started playing chess about 3 months ago. I always knew how to play, but about 3 months ago I started to play for the first time and seriously, and started enjoying it. And then after a little bit I wondered how hard it would be to make a chess game for the Commodore 64. So I decided to try. I chose the Commodore 64 since it's my favorite computer of all time. And so what you're seeing here is the result. It's my chess game for the Commodore 64. I wrote this chess using the cc65 tools for cross-compiling. I made it under a Mac, and I used the Byte emulator. And here you go. There is my chess game. So the main menu: 1 human player, 2 human players, both players AI, and quit the game. So we'll just go and quickly choose something with 1 human player. I'll play white, and I will play the computer on very easy, which makes it move the fastest. So here it is, and you can see it's not very fast, but it does play. So the truth about this is that the AI isn't very good. It's not atrocious, but it's really not great. The game, as I said, is written using the cc65 toolshed, and it's written in C. All of it is in C. It's remarkable how fast this little Commodore 64 was, so that you can write a game like this in C and have it run in any sort of time. So some of the more interesting features about this game: it has the ability to show you what's going on at the board in any given time. So if I press the B key, you can see here a very confusing grid. But basically what it tells you is, if you look in the lower left-hand corner, there is an 8, which means that the piece is white. There's a red 0, which means that this castle is not being attacked by any of the black team, the red team, and a 0 that is white, which says that there is nobody defending this piece. A better way to look at it is to say, show me all of the attackers. So if I turn this on, then while I move around, you can see any tile that is being attacked by an attacker. You can see it highlights the attacker for you. So basically that's the destinations that these pieces can move to as I move my cursor around. Or I can say defenders. So then it tells me which pieces are defending on my team are defending this tile. So that's sort of a nice feature. You can see the cursor turns blue when you select a piece. It's green when the piece has available moves. When it's red, when the piece can't move, is trapped. And if you select it, it becomes blue, and then you can move around. And if I move there, we'll see what the game does. It decides to go after my king. So I will have to take it. Anyway, that is more or less this chess game. You can bring up the menu at any point and switch back to 2 human players, or you can make both players AI. If I say that I want to play on the black side, for example, and I want the AI to be very hard, it'll take up to a minute for it to make a move. And so let me show you something else. Let's just say that we're going to go back and quit this game, start a new game, and we will play with both players on AI, and they will both be very hard. No, let's make it very easy. Okay, so this is more or less how it looks when the AI plays with itself. On the right-hand side, you can see there's a log of moves. It handles all of the legal chess moves this game, including en passant and castling. I mentioned those two because they were a little bit tricky to add because they don't follow the normal pattern. In this version of the game I'm running, it is on the Byte emulator, so I can speed it up by setting Byte into warp mode, and then things happen a little bit quicker. So this is sort of what's happening here. And if you look at this, oh yes, on the log you can see the pluses on the right hand side indicate that that you're in check, and the hash sign indicates that it's checkmate. So the king here, the white king over here is being attacked by the horse. There's the queen and the king, the queen and the king, the king himself, those two pieces can't move there because there's a piece there, that one's got him there, and this pawn has him here. And so the pawn is being defended, so he can't take him either. So that is the reason for the checkmate. It also supports a full undo, so I can undo all the way back. For the undo stack is 255 or 254 effectively long, so I can undo the entire game, or I can redo it all again and review the thing. And at any moment, I can take over and start playing. It's now in both players' AI. Or I can go with, I want to be the human player in white, so it's my turn to make a move here. So I can do this at any time, and just, or I can also just go and say that I want both players to play to see what happens. I've changed it to very hard, and both players are AI, but after I made some tweaks to do that at that point in the game. And you can see even in warp mode, the moves are happening quite a lot slower. The way that the AI works is very simple. It scores each piece as it stands in the source position, and then it looks at all the destination positions, and it scores the values there. What scores and values are is it either gets a positive score, which means it's encouraging it to move, or a negative score, which means it's discouraging to move. So it would discourage a move if it is currently not under attack, not being defended. It would encourage a move if it's taking a piece in that destination, or if it supports one of its own pieces in that destination, or it launches an attack on a more valuable piece in that destination, that sort of thing. And then the difficulty is also controlled by how far ahead the game looks. So the AI will figure its own move, then it'll run the same algorithm on the opponent and select the best moves there or best move there and do that move, and then go back to itself and do that move as well, and go back and forth a few times and accumulate the score, giving the opponent's moves a negative score and its own moves a positive score, and then that final resulting score all the way rolled back for all of its pieces tells it which piece to move now to get the best long-term effect. And that's basically how it works. So what you saw here is the 50-move rule came into effect, where no piece was taken for 50 moves. And that unfortunately happens quite a bit in this. You will see if I undo it that it thinks that these are the best long-term moves for both of it. It has no loop detection or anything like that. So basically each thing is completely separately evaluated. It evaluated those moves and decided that there was just no way that it was going to, that's the best move, and it just gets stuck in that cycle. So that unfortunately does happen. So that more or less is the Commodore 64 version of this game. Whoops, it's in warp mode. Alright, so if you quit the game, then you can also drop all the way back to the Commodore 64, and when you do, you're back to where you were when I loaded the game. It's just got a little stub, and that is it. That's the chess game on the Commodore 64. Now, since I wrote it in C, I can also compile it for something else, and I created a terminal version. There's just one file I had to change, which is the low-level input routines, and most of them are the same since it's C, just using the character input stuff. But this one runs in a terminal, so it uses the curses library, if that means anything to you, and this is what it looks like. This is running on OS 10 for me, and this is my same game running in a terminal. So it's not very pretty, but it does work. And the one thing about this is that it is very fast. So actually, let's just back up. If I back up and I say, all right, I'm going to make them play both AI very hard, you will see that the game is over. It has done all of this. I don't have a particularly fast Mac. It's just that the Commodore 64 is really quite slow for the level of computation that's needed to do a chess game and look ahead and build all the, build a little database of all the moves, what's available, what's valid, that sort of thing. So that is the chess game. I call it cc65 chess because I wrote it using cc65 toolset for the Commodore 64, but as you can see, it runs on anything else, and it would be very easy to port to the Apple II, the Atari, or whatever. Thank you for watching. Bye-bye.